Okay, I'll come back and do problem number 11, but I just want to talk about, an interesting pattern. And I realize in my notes I say I'm dividing, and that's certainly an interesting pattern as well. But there's a pattern to the problem, and that's what, Wells is really expecting you to see, patterns. Let me talk about the patterns, and I'm going to go to the whiteboard to do that. And I'm going to be talking about, patterns that, nowadays are pretty much covered in algebra classes, and that's going to be the sum and the difference of perfect cubes. So this is a difference of perfect cubes. Got a really simple pattern, by the way. X squared plus xy plus y squared. The sum of perfect cubes, x plus y, x squared minus xy plus y squared. All right, so these are the two that most students are told to, memorize, and maybe the teacher expanded those too to let you know that they were certainly valid. All right, so then, the concept is if you go further than that, like if I went to fourth degree, I'll write that down for you, x4 minus y4. Well, if you did this thing just something that perfect squares, let me write this down for you, x squared minus y squared, and then x squared plus y squared. I mean, you could do that, and then you could further factor it, say x plus y, x minus y, x squared plus y squared. You should realize that these things over here are not going to factor, all right? So the bottom line is that I'm going to say there's a pattern to this one as well that's related to these guys up here. I'll write that down for you. X minus y. It's going to look different. I'm sorry. I gotta rewrite it. And let me just write that down again. So I'm going to say x4 minus y4 is x minus y. Again, I'm looking at a pattern, and I'm looking at this pattern over here. All right, let's put this down. What are you going to get? Well, just looking at the pattern, it looks like, you're going to get x cubed plus, and again, I'm looking at a pattern, x squared, y, again, I'm looking at a pattern, xy squared plus y cubed. Now, I realize some students would look at this and look at this and say, no, they can't be the same. Let's go through it. One step at a time, by the way. Show they're equivalent. And what do you get over here? X minus y. And now I'm going to look at these four terms and try to factor it. So what do I see? I see x squared times x plus y squared x plus y. I'm factoring my grouping, by the way. What do you get over here? X minus y. And then I'd factor out the x plus y from this, and you're left with x squared plus y squared. So lo and behold, what do we get? The same thing, right? The same exact thing. All right, so I'm going to claim the pattern, it's really a nice pattern to have. All right, so I want to go and I want to talk about, I'm kind of done with force. By the way, I'm not going to see this. All right, not factorable. All right? Okay, so I'm going to erase, and I want to go to the fifth degree one. All right, we talked about the fourth. I like the odd powers because they're easier. All right? Erase this over here. And I'm going to erase this. And I'm just going to be talking about a difference right now. We'll talk about sums later. I'm going to write the fifth degree one down. All right? So I'm going to write down x cubed. I'm sorry, I don't want to do cubes again, right? I want to do fifth degrees. Minus y5. Well, I'm going to claim it looks like this. X minus y, x4 plus x cubed y. We're hoping you see a pattern when I write this down, by the way. X squared. What am I noticing? The powers of x are going down by 1. Then the powers of y are going to go up by 1. What do I notice? The sum of the exponents is always going to be 4. Plus x y cubed plus y4. All right? So I'm going to claim this is a nice pattern to know. And we can keep doing this over and over again. And you'll see me do it over and over again. Now the question becomes is, what's the other one? Let's write the other one down. It's going to be x cubed plus y cubed. Well, what does that give you? That gives you x plus y, x squared, minus xy, plus y squared. Again, these are things you want to verify. And what I mean by that is, you know, if you're at all doubting about this one over here, what I would do is just multiply it out and make sure you get back what you want to get. All right? Part of that is just, you know, I always say, part of it is just verifying the truth. Let's take a look at this. And I'm going to write this pattern down for you too. All right, so I'm going to write down x5 plus y5. Well, I'm saying, looking at it, I'm going to say x plus y, and then I'm going to, you know, same thing. x4, it looks like it's alternating though, all right, minus x cubed y, alternating, plus x squared, y squared, alternating, x, y cubed, plus y4. Again, I'm going to claim you should multiply this out to verify that this is true. All right? So again, just a simple pattern, and now we're going to use the pattern on the problem. So I'm going to go back to that. We kind of, you know, talked about this, and, you know, certainly doing this problem over here, I realized fifth degree. I guess we just did that, right? So let's write that down. And we'll check the key later. So what am I claiming over here? I'm claiming this is x plus y, and then it's going to be x4 alternating. The powers of x are going down by 1. Powers of y are going up by 1. Alternating. Yeah, nice simple pattern. Again, I claimed I did this by long division. Now I'm doing it by pattern. Are we getting the same answer? X plus y. And get term by term. x4 minus x cubed y, x squared y squared, minus xy cubed, plus y4. Done. All right? It's important you see things by patterns. The way you see things by patterns is by observation, by the way. So we're looking for observational patterns, by the way. That's all we're doing. All right? Thank you.